We are here with Professor Mark Campbell, the S.C. Thomas C. Director of the Sibley School of Mechanical and Aerospace Engineering here at Cornell University. How are you this morning?
I'm good. How you doing?
I'm doing great. What do you think the strengths of the Sibley School are?
I think they probably start with the diversity of the school, the diversity in many areas. Many people think of the Sibley School in terms of the research and the faculty, and certainly that's something they should think about. But educationally, we have many diverse experiences. If you think about project teams, which are a big part of our undergraduate culture, we've been a leader in that for many years, starting with Formula SAE and Al George, who's been doing that for 25 years at least. When I first came here, I did student satellite projects, but Raft and Andrea was working on RoboCup, and since then, it's just taken off since then. And we have 18 project teams, 800 students across Cornell, not just in college engineering, but across the university, many of which are led by our students here. So it's a big part of our culture to be working on different kinds of educational experiences, not just traditional classroom experiences. I think the second thing is probably just the people here in the Sibley School. Again, people think of the faculty and the students, but a big part of the Sibley School, because we're the biggest undergraduate major in the College of Engineering, is the staff. And the staff is a big part of what makes the Sibley School feel a little bit more like a family, a little bit more like a home. The advising staff that we have is just second to none. But it even goes further than that. We have a lot of staff to help with lab classes. There's a lot of one-on-one instruction, even though we are a pretty large major.
What areas of studies and research opportunities does the Sibley School offer to undergraduate and graduate students?
So we in the Sibley School like to think of ourselves as having both disciplines and application spaces. So many faculty like to define themselves by one or the other. The disciplines are typically traditional areas that mechanical engineering is known for, fluid dynamics, control systems, mechanics. Whereas the application spaces, many faculty are thinking of themselves in terms of wind energy, microsystems, biomechanics, robotics. And the nice part about the Sibley School is the faculty can define themselves as one or the other. The way I like to look at this is that we have the building blocks of the disciplines which form a big core of the Sibley School, but we have these wonderful application spaces which shows how our work can be applied all the way to an end application. In terms of the opportunities for students, I think you can go through each level, whether it's an undergraduate or a master's student or a PhD student. Certainly the PhD students and the areas that I just described there's typically some nice one-on-one interactions with faculty in their research areas. Certainly the PhD students typically are working with a group of PhD students with the faculty member, but there's also many opportunities for undergraduate students and master's students. I talked previously about project teams, which is a big part of the Sibley School, but many students work on undergraduate research. I typically have 10 to 15 students in my lab every single year, which is a mix of students and disciplines. And so most Sibley School faculty engage students in that way also.
In which directions do you envision the Sibley School moving toward, both short-term and long-term?
I think the Sibley School, at least the way the faculty think of it, is we're educating the leaders of tomorrow. So we're trying to educate them, giving them the baseline education and the experiences that allow them to be leaders in whatever application space that they want or whatever job they want in the future. Really, the Sibley School is very good for that. In my couple of years as director over the years, I've met a number of alumni, and it's very interesting because many of these alumni are not necessarily doing traditional mechanical engineering jobs anymore. And in the same breath, while they're apologizing for that, they also tell me that the Sibley School gave them what they needed to for their career, whether it is in medical school, whether it's in consulting, whether it's in law school, or being a lawyer. So there's many applications, many jobs that the people in this, the students who are graduating from the Sibley School can take part in. So the question is, how do we do that? What's our vision? I think our vision is staying true to our core disciplines and making sure we have those building blocks, but continuing to move out into new application areas that we will be known for. So Certainly, there are applications we've been known for many years, biomechanics, robotics, and these types of things, but there's new application areas. One of the best examples right now is flexible manufacturing, this 3D printing and new product design. So just as an example, in the past couple of years, we had a faculty search in this area. We hired a new faculty member in this area. And we also, with that new faculty member developed a new design course for our undergraduates. So this past fall, we had a brand new course in product design with some wonderful new examples. And even some of the students are actually trying to sell the products now out of that course.
Thank you, Professor Campbell, for your time, and good luck with leading the Sibley School.